Hi friends, continuing. So in this problem, given that AB is equal to AC, right? Because the triangles are congruent. Congruent means they both are equal, and for the two triangles AD and AE are same. Okay, so you can see we are talking about triangle ABC and ACD. Okay, so and angle AB is equal to angle ACD. Okay, so angle AB is equal to ACD. Okay, now given that AB by AD is equal to AC by AE, because it's already proved, because the triangles are congruent, and given angle A is common. Okay, so this side is equal to this side and angle A is common, right? And AB by AD is equal to AC by AE, because see, when you take AB by AD, AB is equal to AC, so instead of numerator you can substitute AC. Instead of AD, which is the denominator, you can substitute AE, and A is common. This implies that triangle ADE and triangle ABC are similar. Okay, next problem. Given altitudes AO and CE intersect at a point P. So you have a triangle ABC. When you drop an altitude, which means you create a 90 degree such that it comes from this point. So at E there is a 90 degree. Similarly, altitude here, from here, this point A to this line, you create a 90 degree. Okay, it's coming to D. Okay, right? Prove that AEP is equal to CDP. So AEP is equal to CDP. Prove that these two triangles are similar. Prove that ABD is similar to CBE. So ABD is similar to CBE. Friends, the question might look complicated, but the answer is very simple. You just have to apply either AAA, AA, or SAS or SSS. Okay, so here it is mostly AA getting applied. Okay, or AA, double A for that matter. Okay, prove that AEP is similar to ADB, AEP is similar to ADB, okay, and PDC is similar to BEC. So PDC is similar to BEC. So how do we prove that? Note, for triangle AEP and CDP, okay, AEP and CDP, these are two triangles. You have two 90 degrees, right? So for this triangle you have a 90 degree here. For this triangle you have a 90 degree here. Okay, and APE and CPD are same because they are vertically opposite triangles. Okay, so by AA theorem, AEP is similar to CDP. Okay, so that is one proof done. Secondly, for ABD and CBE, angle B is common. Okay, angle B is common, and you have 90 degrees at angle E and angle D. Okay, so those two triangles are similar. Similarly, for AEP and ADB, so that is the third sub question. Okay, angle A is common, isn't it? So, and you have 90 degrees for at each of the triangle, therefore they are similar. Similarly, for PDC and BEC, see this PDC, okay, and BEC, okay, you can see that angle C is common, this angle. Okay, I'll just draw it again here. Angle C is common, that angle is common, isn't it? And you have 90 degrees at angle E and 90 degrees at angle D. So angle D is equal to angle E equal to 90 degree, and again therefore by double A, not triple A, double A, angle triangle PDC is similar to triangle BEC. Okay, so again friends, you just need to think a little slowly and you will get the answer. Okay. Now here we have E is a point on the side of AD produced means extended of a parallelogram ABCD. So you have a ABCD parallelogram. AD you have extended it, produced means extended it, and E is a point on it. Okay, and you have joined B and E. BE intersects CD at F. CD at F. Okay, show that ABE is similar to CFB. ABE is similar to CFB. Okay, so how do we do that? See, we can immediately see that these two angles are same, isn't it? Because angle A is equal to angle C because it's a parallelogram. Note ABCD is a parallelogram, right? So AB and DC are parallel, so is BC and AD. Okay, angle AEB is equal to angle FBC. Okay, angle AEB is equal to angle EBC. Why? Because they are Z angles. Okay, so this angle, okay, again I am drawing here, please see this angle AEB and FBC, this angle are same. Why are they same? Because they are Z angles, because these two are parallel lines and this is the transversal. Okay, and angle C is equal to angle A. Why? Because this is a parallelogram and opposite angles are equal. Okay, so because of AA theorem, now very easily we can say AEB is similar to CFB. Okay, next question. In figure below, ABC and AMP are two right angle triangles. Okay, so they are saying ABC and AMP are two right angle triangles, and show that ABC is similar to AMP. ABC is similar to AMP. That is easy because angle A is common. You have 90 degree for two triangles. AA theorem shows that they are similar, and show that CA divided by PA, okay, divided by PA, right, is equal to BC divided by MP. Okay, because they are the corresponding sides, isn't it? So for triangle ABC and AMP, angle A is common. Okay, see my pen, I am drawing it. Angle A is common, and angle B and angle M are 90 degrees. So by AA theorem, ABC and AMP are similar, and the corresponding sides are also similar. Okay, since the corresponding sides are similar, you can very easily see the AC, who is opposite to 90 degree, right? AC is opposite to 90 degree and PA is also opposite to 90 degree. So they are corresponding, divided by the ones which are not opposite to 90 degree, which is BC and MP, right? So the corresponding sides ratios are same. So that proves it.